My name is Kevin Brennan. I'm a retired math teacher, and I found a way to solve the puzzle from 2 days ago. It's complicated and uses a lot of trigonometry. I hope there's an easier way. I'm just going to run through what I did. I started with two tangent formulas, the basic one where tangent is opposite leg over adjacent leg, and then the half angle formula here. And then to your original sketch, I added the things in red. So I added an altitude for this isosceles triangle, called this leg A, and then I added another altitude for the sideways triangle. This also is going to be A here because we have a rectangle. I let the remaining side of the square equal B. So now the leg down here of this small right triangle is half of A plus B, since that's the whole side length, A plus B. Now I'm going to use that to set up or run my equations here. So the tangent of the 15-degree angle here is going to equal opposite leg A over adjacent leg, A plus B, half of A plus B. And I multiplied everything top and bottom of the fraction by 2 just to get rid of the fraction on the bottom. So then I did the half angle formula, and the half angle formula for an angle is sine of an angle divided by 1 plus cosine. So if I want the half angle of the 15-degree formula, or tangent of 15 degrees, I have to use 30 degrees here and here. So the sine of 30 is a half, cosine of 30 is square root of 3 over 2, and then I multiply the top and bottom of this fraction by 2, just to neaten it up a little bit. So since they're both an expression for tangent of 15 degrees, these have to be equal to each other. So I set them equal to each other, and then solve for B. Did a little cross multiplying and solve for B. What I can do now is use that for substitution later on. So I realize the only way I'm going to be able to figure out that this triangle here is indeed equilateral is to find the measure of angle X here. So I'm going to have to show that that's 30 degrees. From trigonometry, the tangent of a 30-degree angle is square root of 3 over 3. So I'm going to take the tangent from my triangle here. The opposite leg is half of A plus B. That's going to go on top. And then the adjacent leg is B. So then I'm going to set that expression here. I'm going to take that expression and substitute my B value in for, substitute for the B value. So instead of half of A plus B, I've got half of this mess, 3A plus 2 squared to 3A. And instead of the B on the bottom, again, I got the mess on the bottom of the fraction here. Simplify what's inside the parentheses in the numerator. Just add A and 3A, and then they're both even. I got a 4 and a 2, so I can take half of those. So I do that next. And then I factor out the A from all terms, and then the A cancels. And then what I'm left with is 2 plus square root of 3 over 3 plus 2 times square root of 3. I multiply the top and bottom of that fraction by the conjugate of the denominator to get rid of the square root on the bottom. This eventually will simplify down into its FOIL on top and whatever on the bottom. It'll eventually simplify down into square root of 3 over 3. So that shows that the angle must be 30 degrees. And can I imagine about 1% of your readers being able to do that? I hope so, but I kind of doubt it. Thank you.